carboxylic acids are common acids, and we may recognize the carboxylic acid functional group as a carbonyl carbon that's bonded to a hydroxyl group. The hydrogen on the hydroxyl group is the acidic proton, and when that proton is donated, the conjugate base of a carboxylic acid is a carboxylate anion with a negative charge. Acetic acid is the acid in vinegar, and it is a carboxylic acid. It has a Ka of 1.75 times 10 to the minus 5 and a pKa of 4.76. Protonated amines are another type of acid. Ammonium is the simplest protonated amine, and by protonated amine we mean that a proton has bonded to the lone pair of an amine. So the protonated amine can donate its proton, and the conjugate base that is formed is an amine. Ammonia is the simplest amine. Ammonium has a Ka of 6.3 times 10 to the minus 10, a pKa of 9.20. Since its pKa value is larger than that of acetic acid, it is a weaker acid than acetic acid. If you know the pKa of an acid and the pH at which that acid is, you can determine which form of the acid will predominate. When the pH is less than the pKa, the acid form predominates. When the pH is equal to the pKa, there are equal amounts of the acid and the conjugate base. And when the pH is greater than the pKa, then the conjugate base predominates. So if we look at acetic acid as an example, when the pH goes up, that means the concentration of hydronium decreases. So this equilibrium will shift to the right, and more of the conjugate base will form. At a pH higher than the pKa, there will be more conjugate base than acid. At a pH lower than the pKa, there will be more hydronium. Remember, a low pH means higher amount of hydronium. So as we increase the amount of hydronium, the equilibrium will shift to the left and more of the acid will form. So at a pH less than the pKa, the acid is the form that predominates. When the pH is equal to the pKa, there are equal amounts of the acid and the conjugate base.